Hello grade 11s and welcome to this theory video on Coulomb's law. Coulomb's law states that the magnitude of the electrostatic force exerted by 2-point charges on each other is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance between them. In symbol form, we have that the magnitude of the electrostatic force is given as F. And it is very important to understand that this is only the magnitude of the electrostatic force. We have a proportionality constant in the formula, K, and K has a constant magnitude of 9 times 10 to the power of 9. What is nice is that you'll always find the value of K in your table of constants on your formula sheet. So you don't need to memorize it, although if you do already know it off by heart, it's a good indication that you've been studying pretty well. We also have in this formula Q1 and Q2. This is the charges that are being multiplied by each other. And that is why in Coulomb's law, stated in words, we speak of the product of the magnitude of the two charges. The product means we are multiplying together. Very, very important is that in this formula, whenever you plug in the charges, you're only going to plug in the magnitude. You're not going to place into the formula negatives if your charges are negative. And this is because Coulomb's law says that the magnitude of the electrostatic force is independent of whether the charges are positive or negative. In this formula, we divide by r squared. R is the distance between the charges, and we must always remember to square it, because in words, Coulomb's law says that the magnitude of the electrostatic force is inversely proportional to the square of the distance between them. Force is, even if it's an electrostatic force, is measured in newtons. We say that the SI unit for charge is Coulomb, so make sure that you know how to convert from microcoulomb, nanocoulomb, etc. to Coulomb. And distance is measured in meters. Once you're familiar with this formula that will always be provided to you on your formula sheet, the relationships stated in Coulomb's law become easy to remember. The electrostatic force is directly proportional to Q1 multiplied by Q2. And the same electrostatic force is inversely proportional to the square of the distance between the charges. Now, as I've kept saying, this law is only going to provide us, or this formula is only going to provide us with the magnitude of the electrostatic force. But we all know that force is a vector. So the question becomes, how are we going to determine the direction of the electrostatic force? Well, to determine the direction, we need to check to see what type of charges we're dealing with. Do we have like charges, like a positive and a positive charge? Do we have like charges, like a negative and negative? Or do we have unlike charges, like a positive charge and a negative charge? If we look at the first situation, where we have two positive charges called Q1 and Q2, I can ask you to draw a free body diagram for either one of these charges indicating the direction of the electrostatic force. The free body diagrams will look something like this. And the reason is because if we make Q1 the focus and we say, in which direction does Q2 exert or apply an electrostatic force on Q1? Then we will say, since they are like charges, there's a repulsive force between them. So Q2 is going to push Q1 away. And therefore, on the free body diagram, where this dot represents Q1, you can see that the electrostatic force on Q1 is to the left. If we are making Q2 the focus, then we say again, what type of force exists between these two charges? And we know that Q1 is going to push Q2 away. Therefore, the free body diagram, in which we represent Q2 as a dot, indicates that the electrostatic force on Q2 is going to be towards the right. In this case, Newton's third law still applies. And we can therefore come to the conclusion that the electrostatic force that Q2 exerts on Q1 is equal in magnitude but opposite in direction to the electrostatic force that Q1 exerts on Q2. Please remember this, Newton's third law still applies. If we take a look at the situation below this, where we have two negative charges, we know that between two negative charges, we're also going to have forces of repulsion. So therefore, if we are looking at QA and QB, and I ask you, in which direction does QB exert an electrostatic force on QA, then we're going to say that QB is going to push QA away. And we can say that QA is going to push QB away, right? And that is how we're going to determine the direction of the electrostatic force on each one of these charges. If we're looking at QX and QY, in this situation, we have unlike charges. And unlike charges attract each other. So if we focus on QX, then we know that QY is going to pull QX towards itself. And QX is going to pull QY towards itself. So in this case, they're going to pull each other. And this is why the forces are in the directions indicated on your screen. Very important is that Newton's third law applies in each of these cases. This force is equal but opposite to this one. And over here in the last case, this force is equal but opposite in direction to this one. And this is how you're going to decide on direction. Again, to calculate the magnitude, you're going to make use of the equation provided by Coulomb's law. But to determine the direction, you're going to check to see what type of electric charges, positive or negative, you're dealing with. Now, based off of Coulomb's law, we can look at different graphs and see the relationships between the different variables in Coulomb's law. Firstly, we can plot the relationship between the electrostatic force and the product of the magnitude of the charges. And as you can see, here we have an increasing linear graph that passes through the origin. The reason the graph looks this way is because as the product of the magnitude of the charges increases, we expect the magnitude of the electrostatic force to increase as well. And this can be shown by a graph that looks this way. If we are looking at the relationship between the electrostatic force and the square of the distance between two charges, or the centers of two charges, then we have a graph that looks like this one. We can see over here that as the square of the distance between the two charges increases, the electrostatic force decreases. And this is because they are inversely proportional. The last graph can be a bit tricky to understand. We are saying here, or showing the relationship between the magnitude of the electrostatic force and 1 over the square of the distance between the charges. We say that according to Coulomb's law, the magnitude of the electrostatic force is inversely proportional to the square of the distance between the two charges. But that means that the electrostatic force is directly proportional to 1 over the square of the distance between the two charges. And that is why in this case we have an increasing linear function that passes through the origin. Familiarize yourself with these graphs, as you can be asked about these either in practicals, or we can have a question in which a practical takes place, and these questions can come up in your homework, your tests, or your exams.